Hi students, welcome to the next class. We discussed resistors connected in series, parallel already. So in series means what is the effective resistance formula we said? RS is R1 plus R2 plus R3. So what is same we said? Current is same, voltage is different. If three resistors connected in parallel, if three resistors connected in parallel, what is the formula we said? 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. In this, what is same we said? Voltage is same. Current is different. In this, current is same. Voltage is different. If n identical resistors, if n identical resistors connected in series, then what is the formula? R plus and so on R. It is going to be n R. Rs is equal to n R. Same like that, if n identical resistors connected in parallel, 1 by Rp equal to 1 by R plus 1 by R plus 1 by R plus and so on. So how many 1 by R's are there? N 1 by R's are there. 1 by Rp. So Rp is equal to R by N. So you have to remember, in case of capacitors, it is going to be different, isn't it? So that one please remember. Now Rs by Rp. Rs by Rp means NR by R by N. That is going to be N square is to 1. So you have to remember like this. Next, what is the voltage across each resistor? They will ask V1, V2, V3. If applied voltage is V. So for this, what is same? We said current is same. So current is same means I1 is equal to I2 is equal to I3 is equal to I. So what is I1? V1 is equal to I1 R1. Then I1 is V1 by R1. Now what is I? Among all these, V is equal to IRS in series combination. At the time, V is equal to IRS means R1 plus R2 plus R3. So substitute in this. What is I1 now from this? I1 is V1 by R1. What is I now? From this, I is equal to V by Rs. Therefore, V1 is equal to R1V by Rs. That is going to be R1V by R1 plus R2 plus R3. So, with our common sense, we can write V2. Whenever we got V1, we got R1. Whenever we got V2, you will get here R2V by R1 plus R2 plus R3. V3 also you can write R3V by R1 plus R2 plus R. So these are important equations, voltage across first resistor, second resistor, third resistor. Same like this. In case of parallel combination, what is the current I1, I2, I3 they will ask. For this case, what is same? For this case, what is same? We said current is same, therefore we equated currents. Now in this case, voltage is same. V1 equal to V, V2 equal to V, V3 equal to V. Isn't it? What is V1? Same. I1 R1. So I1 R1 equal to what is V? I RP. So this is RP. This is I. Voltage is V. I RP. Correct? Now you got I1. I1 is equal to RP by R1 into I. Now what is RP? When three resistors connected in parallel, what is resultant resistance? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R. So from this Rp is R1, R2, R3 by R1, R2 plus R2, R3 plus R3, R1. This one we have to substitute here. I by R1. In place of Rp, what we can write? R1, R2, R3 by R1, R2 plus R2, R3 plus R3, R1. So one R1 will be cancelled. Therefore, you got I1 is R2, R3 by denominator same. R1, R2 plus R2, R3 plus R3, R1 into I. Correct? So again with our common sense, whenever I1 we got here, R1 not came. Here whenever V1 is there, R1 only there. Like that. Now say, what is I2 now? I2 is R1 R3 by R1 R2 plus R2 R3 plus R3 R1 into I. Now what is I3? R1 R2 by R1 R2 plus R2 R3 plus R3 R1 into I. So this is about I1, I2, I3. This is about V1, V2, V3 when resistors connected in parallel and series. So this will be small difference will be there for capacitors and resistors. So three different resistors in series R1, R2, R3. Then effective resistance is always greater than when resistors in series. Always greater than maximum resistance among the resistors. That is 1 ohm, 2 ohm, 3 ohm. Now effective resistance is greater than 3 ohm if resistors in series. If parallel means effective resistance is less than R minimum. Minimum means here 1 ohm. Effective resistance will be less than minimum means that those combination will be, that combination is in parallel. Effective resistance is greater than maximum among the given resistors means those are connected in series. Let us assume 10 ohm, 20 ohm, 15 ohm. Your resistance, effective resistance is greater than 20 ohm. Then combination is series. Effective resistance is less than 10 ohm. Then combination is parallel. This is different for capacitors. Please remember capacitors in series, capacitors in parallel. You got different. Differently you got this because formula is different. Don't get confused with that. Okay? Thank you. One is same. Which is same means when capacitors parallel, voltage is same. When resistors parallel, voltage is same. When capacitor series, what is same? Charge is same. When resistor series, current is same. Because through resistors, current will flow. Capacitor is used to store the charge. In both the cases, voltage is different. Isn't it? Like that you can remember. Thank you.